Here we're going to look at problems 5 through 10 on the handout on the quiz review, but specifically we're going to find the explicit and recursive formulas for arithmetic and geometric sequences, and we're going to find terms in those sequences. Alright, let's start out by finding the recursive formula. Alright, the recursive formula for arithmetic. Now it's arithmetic because I have a common difference here. I'm adding 3 each time. To get from negative 34, I add 3, I get negative 31, and so on. Alright, so what we're going to do here is have our common difference. And so that would be negative 31, subtract negative 34, which ends up being plus. Okay, and so we get 3 for our common difference. And if you notice, if I add 3 each time, I'm going to get, if I add 3 to negative 31, I get negative 28. Add 3 to negative 28, I get negative 25, and so on. Okay, so that would be our common difference. Alright, now our formula is going to be a sub n is equal to an minus 1 plus d. And then we need to know what the a sub 1 is. Okay, so in this particular case, we're just going to substitute in a sub n is equal to an minus 1 plus 3, because that's our common difference, and then a sub 1 is equal to negative 34. So that is our recursive formula for this particular one. Now, our explicit formula, I'll take on the general form of a sub n is equal to a1 plus d times n minus 1. We're going to substitute in, so a sub n is equal to a1, which in this case was negative 34. So it's going to be negative 34 plus the difference, which is 3 times n minus 1. Okay, so we're going to simplify this. We're going to distribute the 3. So we end up with a sub n is equal to negative 34 plus 3n minus 3. Combine, so we end up with a sub n is equal to negative 37 plus 3n. Okay, and so that's our explicit formula. Okay, now we want to find the 25th term. To find the 25th term, we substitute the 25 in for n. So a sub 25 is equal to negative 37 plus 3 times 25. Okay, and then so when we multiply and then end up adding a negative number, we end up subtracting, but anyway, we end up with 38 as our 25th term. Okay, so that was number 5. Let's look at the next problem. Alright, in this particular problem, okay, we still need to make sure if it's arithmetic or geometric. This one's an arithmetic one, and then let's prove it. Our common difference is going to be negative 32 minus negative 22. Okay, so when we do that, we're going to end up adding and we get negative 10 for our common difference. Okay, so our common difference is negative 10. So let's come up with a recursive first. The recursive formula will be a sub n is equal to an minus 1 plus our common difference. So in this case, it's going to be negative 10, and our first term is negative 22. So that's our recursive formula. Alright, now we're going to find the explicit formula. Alright, now the explicit formula, okay, we're going to need the a1, so we're going to have a sub n is equal to a1, which is negative 22, okay, plus our common difference, which is negative 10 here. So we'll have minus 10 times n minus 1. We're going to go ahead and distribute and then simplify. So we end up with negative 22 minus 10n, okay, plus 10. We're going to combine like terms so that we end up with a sub n is equal to negative 12 minus 10n. Okay, I'm coming up with negative 12 because I'm adding the 10 and a negative. Positive number, negative number, subtract. Anyway, we end up with negative 12. So that's our explicit formula. Okay, now our next step to find the 25th term, we're going to take 25 and plug it in for n. Okay, so a sub 25 is equal to negative 12 times negative 10 times 25. Okay, so when we multiply that, we're going to end up with a sub 25 is equal to negative 12 minus 250. So we're going to end up with, for the 25th term, 262. Negative 262. But anyway, so the 25th term is negative 262. Okay, so now we found the recursive, explicit, and the term for a sequence. This is actually an arithmetic sequence. Alright. Now, here in the 7th problem, alright, we're doing the same process as far as finding explicit, recursive formulas, and then we're going to find the 11th term. Now, this particular one is going to be geometric. So we have a common ratio, because if we divide 9 by 3, we get 3. So our common ratio is 3. Okay, so now for our recursive formula, what we're going to have is a little bit different formula than with the arithmetic. So the recursive formula is going to be a sub n is equal to a1, an minus 1 times r. Okay, r can be in front or back. It doesn't matter how you multiply, and then we need the first term. Okay, so for this one we'll have a sub n is equal to a n minus 1, and our ratio is going to be 3. So I'm going to put times 3. And we need a1, which is 3 as well. So there's the 3 is the common ratio, and 3 is the first term. So that's our recursive formula. Now our explicit formula is going to be a sub n is equal to a1, okay, then r to the n minus 1 power. So a sub n is equal to a1, which is 3, times r, which is 3 as well, to the n minus 1 power. I'm going to clean that up. So 3 n minus 1. Okay, so that's our explicit formula. Okay, now to come up with the 11th term, we're going to take 3 times 3 to the 11 minus 1 power. So we end up with 8, 11 is equal to 3 times 3 to the 10th power. Alright, and so 3. Alright, so we should end up with a sub 11 is equal to, okay, and so that's our 11th term. Alright, and then I'm just going to check the answers, but that's all the different things we found. Alright, and so just to check our answer, that's what we came up with for that term. Now, again, these are our two explicit formulas. Well, we have not two. We have an explicit formula and a recursive formula for that one. Alright, so let's go ahead and look at 8. Alright, 8. Now here we're oscillating back and forth between a positive and a negative number, so it's not going to be arithmetic, because arithmetic, you're either going to be decreasing or increasing. You're not going to be going back and forth. Okay, so for this one, it's probably geometric. So let's take negative 12 and divide by 3. We get negative 4. Okay, just to double check for our common ratio, I'm going to take 48 and divide by negative 12. I still get negative 4. Alright, so our common ratio is negative 4. Alright, so let's find the recursive formula first, and then we'll go find the explicit. Alright, so our recursive formula is going to be a sub n is equal to a n minus 1, okay, and then times our common ratio, which is negative 4. So I'm going to say times negative 4, and our first term is 3. Okay, so that's our recursive formula. Okay, now let's find our explicit formula. The explicit formula in this case is going to be a sub n is equal to a1, which was 3, times r, which in this case is negative 4 to the n minus 1 power. So that's our explicit formula. And then we want to find the ninth term. So this will be the ninth term is going to be 3 times negative 4 to the 9 minus 1. Okay, so we're going to end up with 3 times negative 4 to the 8th power. So we take negative 4 to the 8th power and then multiply that number times 3. Okay, and so we end up for our ninth term, it's going to be negative 196608. Okay, and so that's our ninth term. And remember, no matter what, if you mess up on the calculator, it may give you a negative number for this part. Okay, but it's got to be positive. Okay, so for this one, it has to be positive 196608, because anytime you take this to a positive number, anytime you take a power's positive, you end up with a positive number. Okay, so we end up with that for that particular one. And to double check our answers, this is what we come up with. Okay, so this is not negative, this was positive, remember that. And if you ended up with a negative number, again, just check how you put it in the calculator. Alright, now we got two more of these. Okay, again, we're oscillating back and forth, so it's probably going to be geometric. So let's take negative 12 divided by 4, gives us negative 3. So our common ratio is negative 3. Okay, the recursive formula is going to be a sub n is equal to an minus 1 times r, which in this case is negative 3. A sub 1 is equal to 4. So that's our recursive formula. Okay, the explicit formula is going to be a sub n is equal to a1 times r to the n minus 1 power. So a sub n is equal to 4 times negative 3 to the n minus 1 power. Okay, so that's our explicit formula. And then finally, our final answer is going to be a sub 9 is equal to 4 times negative 3 to the 8th power. Well, I'll go ahead and go through the steps. It'll be 9 minus 1, so we get 4 times negative 3 to the 8th power. Okay. Now I want you to think about this. Should we end up with a positive or negative number when we take to the 8th power? Alright, so when we take 3 to the 8th power, or negative 3 to the 8th power, we end up with 65061, and we're going to take that number and multiply it times 4 to get our final term. Okay, we end up with this. Okay, so a sub 9 is equal to 26244. So that's our ninth term. Okay, and just to check our answer, we'll see what the computer came up with. And the computer came up with this, and that's what we came up with as well. Alright, so we'll go ahead and do problem 12 as well. Again, sorry. It's geometric, because again, well, if it's not obvious, we take 12 divided by 4. Okay, that gives us 3. Take 36 divided by 12. That gives us 3. Okay, so we have a common ratio. So that's geometric. So for our explicit, a sub n is equal to an minus 1 times 3. a1 is equal to 4. So that's the recursive formula. Okay, now to find the explicit formula, it's going to be a sub n times a1 times 3 to the n minus 1 power. Again, 3 is our common ratio, 4 is the first term. Okay, and so that's our explicit formula. Okay, and then last, to come up with the 12th term, a sub 12 is going to be equal to 4 times 3 to the 12 minus 1. Okay, so we end up with a sub 12 is equal to, you cannot multiply 4 times 3 here. We have to take 3 to the 11th power first. It's going to be 4 times 3 to the 11th power. Okay, so we end up with this, and then we're going to multiply that times 4, And so a sub 12 is equal to this. And that's our 12th term. So we have our recursive formula, explicit, and then finally we have our 12th term. Okay, and so that's how we would do those.